All right, we are going to look at the constant of proportionality. So some important vocabulary that we need to know is, what is the constant of proportionality? You're going to see us abbreviated as COP just so it can fit easily on the notes. But what it is it's a constant ratio of one variable quantity to another to which it is proportional. So the key part is constant means it's the same, right? And it's proportional. So we've already talked about proportional relationships. It should simplify to the same ratio. So how am I going to find it? We're doing the change in y over the change in x. This is important because normally when it's presented to us, whether it's in an ordered pair or a table or whatever, x usually comes first and then y. So people will get this wrong. When we are calculating it, you have to put y on top. It's the change in y. And it should be written as a fraction even if the denominator is 1, which is what it's going to be every single time for this because it's a proportional relationship and they all simplify to the same rate. So first up, constant of proportionality from these tables here. So I'm just going to pick any two values, remembering that on the table, x is on the left, y is on the right. So I have to put my y on top. I'm going to start with my bigger y of 80 minus my other y of 40 over, if I started with 80 for y, I'm going to start with 10 for x. 10 minus 5. So 80 minus 40 is 40 over 10 minus 5 is 5. 40 over 5 is 8. So 8 over 1, because remember we want to write it as a fraction each time. That is our constant rate. What you're going to realize is, well, yeah, 40 divided by 5 is 8. 80 divided by 10 is 8. 120 divided by 15 is 8. The reason that we still want to practice it this way is in every scenario that you're ever going to get, it's not always a constant of proportionality. It might not be a proportional relationship. So we want to practice calculating it this way in case it's not. But for the sake of this lesson, they should all simplify to a ratio over 1. Here, I'm just picking my two values. Reminder that x is on the left, y is on the right. So we're going to find our change in y, 142 minus 71 over 4 minus 2. So 142 minus 71 gives me 71 over 4 minus 2 is 2. So technically this is the simplified fraction, but remember we want it to be a ratio over 1. So we are also going to divide it by 2. 2 divided by 2 is 1. 71 divided by 2 is 35.5 or 35 and a half over 1 because we want it to be that ratio over 1. 35 and a half over 1 is our constant of proportionality. Now let's look at these vertical tables. Same thing, I'm still going to pick just two values. You'll notice I always just kind of start with the bottom two. Here it labeled for us x, y. Remember, x is first, y is second. X is first, y is second, but when we actually plug it in, we flip that around. So I'm going to start with my bigger y. We're doing 80 minus 30 over, since I started with 80, we're going to start with 8. 8 minus 3. 80 minus 30 is 50. 8 minus 3 is 5. These both divide. If we just divided 50 divided by 5, we get 10. But remember, we want to write it as a ratio over 1. So our constant of proportionality is 10 over 1. All right, next up, same thing. I'm just going to pick the first two x and y value. Okay, we have to do y first. I'm going to start with this bigger y right here. So 1,212 minus 808 over, since I started with this y value, I'm going to start with this x value, 6 minus 4. So we're going to subtract on top. 1212 minus 808 is 404 over 6 minus 4 is 2. And we're going to simplify that. 404 divided by 2 is 202 over 1. So our constant of proportionality is 202 over 1. Now let's look at it from graphs. So we did it from the table, let's look at it from the graphs. What is important is please pay attention to the increments on the graph. It doesn't always go up by 1. So first thing, I always look for clear points. This has a ton of clear points, so I can go anywhere on here. I'm just going to go to the basics. So I'm going to look at that clear point. Where does it match up with the y-axis? Where does it match up with the x-axis? So remember, our y is the vertical, our x is the horizontal. So the change in y, it goes from 0 to 10, it's going up 10, over the change in x is 1. So 10 over 1, that's already simplified for us. That is our constant of proportionality. Okay. All right, and really, if we're talking about what does it mean, I'm going to add that in here. This means the total water consumption per day. So it's in liters. So this means 10 liters per day. All right, over here, finding clear points. It looks like they all are going through these clear points right here, but that's not 1 over 1. The y value is 15. The x value is 3. So remember, y, x. So it's 15 over 3. 15 divided by 3 is 5, or 5 over 1. So our constant of proportionality is 5 over 1. This means 5, what was our y? Toys. 5 toys per carton. All right, number 7, looking for clear points. Like if I look right here, that's not going through a clear point, but right here it does. So we're looking at where does it meet up. Our y value is 6. Our x value is 1. So that is already simplified for us. 6 over 1 is the constant of proportionality. What does it mean? It means $6 per soccer ball. All right, now we're going to look at it using an equation. So the constant of proportionality is the number being multiplied by the independent variable, or the x. So our equation should be in the form like y equals, or potentially a different variable there. The number that is multiplied by the x is our constant of proportionality. So right here, the number being multiplied by x is 54. We write it as a fraction over 1. Next one, this y, and the b is kind of being the y in this scenario, and the a is kind of being the x. So this number here that is being multiplied by a, that is our constant of proportionality. So 129, remember to write it over 1. And number 9, even though it's flipped around, it doesn't matter. This is still the number that's being multiplied by the x, 2.3. And even though it's a decimal, we're going to write it as a fraction over 1. And then last up, finding the constant of proportionality for each word problem. So some things to note. We're still simplifying the ratio of y over x. X is our independent variable. Key thing to note in a problem, oftentimes if we're talking about time, hours, minutes, seconds, days, years, weeks, anything like that, that is representing that x variable here. Versus y is our dependent variable. And generally when we're talking about money or totals, that is going to be dependent, because unfortunately money depends on things. You get money by working or whatever. We don't just get money for free, unfortunately. So let's set this up. Bob's Burger Barn has a special deal of 4 hamburgers for $6. I see that $6, that's talking about money. That is representing the Y, so that is going to go on top. 6 over the other number of 4, which I could simplify that to 3 over 2, but I want to divide that so it's over 1. 2 divided by 2 is 1. 3 divided by 2 is 1.5, or 1.5. So the constant of proportionality is 1.5 over 1. Number 11, Kelly babysat 5 of her cousins over the weekend. She received $85. I see that money. That tells me we're talking about Y, so that is going on top. It's $85. The other number we're talking about is 5. So 85 over 5. When I divide, 5 divided by 5 is 1. 85 divided by 5 is 17. So our constant of proportionality is 17 over 1. Number 12, Ken has a total of 336 jelly beans. He said he opened 6 bags of jelly beans. So I don't see time, I don't see money, but I do see total. It says total of 336. Totals tell us the Y variable. So that's going to go on top. 336 divided by 6 bags. I'm going to divide that by 6, and we get 56 over 1 as our constant of proportionality. All right, last one. A student types 135 words in 45 seconds. I don't see time, I don't see money or totals. I do see time, so that's representing our X, which means the words is our Y on top. So 135 over 45. If I divide those both by 45, 45 divided by 45 is 1. 135 divided by 45 is 3. So we get a constant of proportionality of 3 over 1.